The last concept in the chapter of force is uniform circular motion. It's a very important concept. There are 5-6 points, that's all in this, and if you know 5-6 points, definitely there will be one marker coming from this topic. Uniform circular motion, as the name suggests, this is a circular motion and it is a uniform motion. So circular motion means the body is traveling in a circle, so that is what the circular motion is. And then uniform means, what is uniform in this? The uniform is speed is constant, speed is uniform. That means, let's take example is take a string and then tie a stone at the end of the string. If you start whirling it around, so the stone experiences a uniform circular motion. Then if you measure the velocity speed of the stone at a particular point, if it is 10 meters per second, and then if you measure it another point, there also it is 10 meters per second, and measure at one more point 10 meters per second, here also same and here also same, then this body is stone is said to be in uniform circular motion. So in a uniform circular motion, speed is constant. Every point is important here. So speed is constant. But it is important that the velocity is not constant. Speed and velocity, the difference is one is a scalar, another is a vector. Speed is a scalar, velocity is a vector. So speed does not have the direction, but the velocity has a direction. So if you see here, the velocity of the stone at this point is along the tangent to the circle at that point. So this is the direction of the velocity here. If you see the velocity at this point, this is the direction of velocity. It is the direction of the velocity here. So here it is the direction of the velocity. This is the direction of the velocity here. So the direction of the velocity is changing at every point in the circular motion. That means velocity is not constant. Velocity is changing, but speed is constant. Very important point to note. Body has acceleration. Whenever you have a change in the velocity, acceleration will be there, because acceleration is nothing but final velocity minus initial velocity. So these two velocities are not same, since they are different. So the acceleration, there will be an acceleration. And then what are the forces acting or the present in a uniform circular motion? You come across two forces, one centripetal force and a centrifugal force. It is important to understand the difference between a centripetal force and a centrifugal force. For example, take centripetal force and centrifugal force. One force, that is centripetal force, is a real force. Centrifugal force is a fictitious force or an imaginary force. Centripetal force acts towards the center, very important. So here, the centripetal force acts towards the center. Centrifugal force acts away from the center, and both of them act on the body. So, but one acts in one direction, the other one in exactly the opposite direction. Centripetal force always towards the center, centrifugal force always away from the center. And then centrifugal force is away from the center. Which force is really needed for uniform circular motion or a circular motion? Do we need both the forces? Do we need one force? If one, which is the one? So the answer to this question is very important. We need only centripetal force. We do not need centrifugal force for a uniform circular motion. Centripetal force is the only necessary force for a circular motion. Centrifugal force will be felt, or the observer feels as if that force is present. Otherwise, in reality, that force is not at all present. So the only force that is needed for a circular motion is centripetal force.